In this video, let us discuss one of the interesting topic, and we have considered a real-time scenario where we have considered Hotstar as a use case where they try to implement a real-time technology, and so how they are able to kind of capture like a millions or billions of emojis in the real time during some uh, like match or during some event, and how they are able to process these events in real time as a events, right? So emojis as a events in real time and then send it back to the interface. So yeah, I mean, at a high level it might look simple, but so you can imagine how many peoples are watching in a World Cup match or in the IPL finals, and how much emojis that each person is generating, and you have to capture all these emojis and send it back in real time with very less latency, right? So that's quite important here. And so we will take this example and let us see what are the different technological stack that their Hotstar is using, and how they are able to solve the puzzle basically using a different kind of architectural principles or different kind of technologies, how they choose different technologies, and how actually finally it has resulted in good results basically. So that is the thing you can expect in this video. So before proceeding, if you are new to this channel and haven't subscribed for this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So as you can see, like during any live match, right? So you'll be interested to know. I mean, you will be interested to share what exactly you feel your emotions are. Like as a viewer, you will definitely. As an audience or as a viewer, right? So you'll be able to click on the different emojis. Say, for example, if the Dhoni is batting, you want to see six scores, and say if Dhoni is keeping, in that case, you want to uh, get him the wickets, right? And in the same way, if the Kohli is batting, so you want to have some boundaries in the other, like similarly, right? So that's how, as a viewer, you express your audience, and so these, like as you can see, there are like a lot of emojis getting generated, and whenever you generate any emojis as an end user, so that has to be captured in real time as the game proceeds, and there will be a whenever a game change, right, as the game go on, so the emotion changes and the mood swing of audience changes. So we have to capture it in the real time, and as soon as possible it has to be sent to the interface back to the Hotstar app, right? So like basically Hotstar captures billions of such emojis, and process them basically. And let us see what exactly kind of how the technological stack looks like and how exactly they're able to achieve this. So before exactly jumping into the architectures and other things, right, let us see the key design considerations. What are the key design considerations? I mean, what Hotstar has kept in their mind are critical for this kind of use case. So basically, to start with the scalability and auto scaling, definitely whenever we talk about data with a huge volume, especially the real-time data, right? So then auto scale or enabling the auto scaling or taking care of a scalability is a key thing. And because we don't know when the traffic will increase, and we are not sure about when it will decrease, and it is very dynamic in nature. So with respect to the cost, with respect to the infrastructure necessity, it is definitely important to enable the autoscaler, and that's what Hotstar did. And they also used the load balancers and also configured auto scaling to scale the resources up and down basically. And next is a decomposition. So decomposition is nothing but when we talk about this is nothing but a distributed computing, what we are talking about nowadays, right? That's what Hadoop does or big data does. And what that means is breaking the chunk of a problem into multiple basically, yeah, multiple chunks, and then able to process them individually, and then like without any without any dependency between each other. And so that will exactly where you call it as a distributed computing, and you independently kind of compute each each chunks, and you'll be able to process them faster. So this is also one of the key consideration we can see, and the asynchronous nature, why they are using asynchronous, right? So what is synchronous and what is asynchronous? In asynchronous, whenever a message is sent, right, we have to wait for the response. Okay, it is a like it's a two-way handshake. Basically, synchronous is a two-way handshake. Whether like you have to wait, right? There is no other choice. But in case of asynchronous, you do not wait for any acknowledgement. In synchronous case, if any case of a failure, right, we couldn't retrieve the configuration at both the server and the client end. But in case of asynchronous, whenever we write the message to the local buffer and response with success to the client, a message from the buffer could be written asynchronously to the queue. So the only downside that we can see is that if not handled properly, this could result in a data loss. The asynchronous could result in a data loss. But here, Hotstar, why they have considered this is so they think that they can afford the data loss here, because these are just emojis. If one or two emojis are dropped in between, so they can afford that risk, because it's not of much importance. And but what is important is like importance is the to keep the latency very less. So here Hotstar is playing the trade-off where they want to reduce the latency, but they can take a risk of choosing the asynchronous way of doing it. uh, Even though the latency is, I mean, even though we are losing the data, but we are getting the high, I mean, low latency, very low latency here. So that's the reason. And coming to the technological background, right? So the Hotstar is using the Golang as a programming language here, and has why they are using Go language is the Golang supports has a great support for the concurrency, and also Go routines. There is a something called as Go routines, which are very lightweight threads that can be execute function asynchronously. So that we can see more detail in the coming slides, basically. Yeah. So how they have implemented is to handle the request. So to handle the request asynchronously, it's a two-way handshake. But as I was telling, so asynchronous doesn't wait. Actually, it's still a two-way handshake, but it doesn't wait necessarily if the response doesn't come. So the what happens is the downside is like it is not handled properly. It could result in a data loss. But as I was mentioning, right? So the data loss is not a big concern for Hotstar, because these are the emojis case. So that's the reason they are choosing the asynchronous approach here. And to implement this, Golang, as I was mentioning, it's having a great support for the concurrency, and also it has implementation for Go routines, which are lightweight threads that can execute functions asynchronously. So that's what it is serving their purpose actually. So that's the reason they are using they're choosing the Go language as a programming language here to handle such asynchronous requests. Okay. And coming to the implementations, right? So let us consider how the data is being processed. So the use case here is the in the real time we have to consume the data in stream from the Kafka and compute aggregates of the data over an interval. Okay, time interval should be small enough to provide a real-time experience to the user. So that's the use case that we see here. Okay. Uh, so that means the capturing of the data is key here, and when we get capturing, so they are using from the Kafka engine, and they are able to compute, and it should be able to compute data over an interval of time. That means there will be micro batches in the stream of the data that is coming in, and it has to be processed within that time interval, right? So how they are implemented is like after considering they have considered Flink, Spark, Storm, Kafka streams. So they have decided to go with the Spark here. In this case, for the processing purpose, they are using Spark, because Spark is good at processing the micro batches and also aggregates, which are essential for the use case, and also better community support compared to the competitors like Flink, because Spark is having a good community, and there are a lot of developers, and there is a good support also to the Spark from the different communities, data engineering communities. so you can get a good amount of support. So that's the reason. So here for the implementation purpose they have used Spark, but for the distribution to making it asynchronous basically, so they have used Golang as a programming language. Yeah. So this is about the data processing, right? So next, let us see about the data delivery. So once the data is processed, it has to be delivered back to the end user. As you can see, like after API, I mean, using the API, right? We are able to process. I mean, we are able to fetch the data and then process it, and then the final thing is you have to deliver it back to the user interface. So that is the final use case where after processing, how do you deliver the message back? So here they are using the PubSub as a delivery mechanism. PubSub is a real-time messaging infrastructure built at Hotstar to deliver message to the users in the social feed. Basically, it's a real-time messaging infrastructure. Basically, it'll be a kind of a API that will be built because it's like a posting a message back to the device. So it'll be a kind of a API is what I believe, but I'm not sure about how what is the in detail. I mean, how they are able to implement this, but I'm sure internally it will be using some kind of a API here. And so what they are doing is that they're writing a simple Kafka consumer in Python, and consumption rate depends on the batch of the duration. Basically, this batch duration is what you can tweak as a configurable parameter, like 2 seconds, 3 seconds, 5 seconds, how much as per the requirement. But so the important thing here is to note they are using a Kafka consumer in Python. So for delivering, right? So they are using this PubSub as a real-time messaging infrastructure, but as a programming language to implement it, they're using Kafka consumer in Python. So basically, why we are giving all these examples is like it will give the better idea like how there are different technologies. So it is not like using one technology you can do all the things, right? So it is like you have to choose the technologies based on the real-time use case, based on the necessity, based on the latency, based on the key considerations. It actually depends on like each and every use case. So that's how a smart solution architect, as a smart solution architect, you have to think which component to place where. So yeah, so now let us move quickly to the, yeah. In fact, before moving, right? So here, let us take an example. I mean, let's say that it's set to 1 second. The configuration parameter what we're taking it is set for 1 second, right? The consumer would receive a message per second. Okay, so we are, and the performance, the normalization over the data and send top emojis to the to pops up. So client will receive messages from pops up and shows the emoji animations in their smart devices. So that's a key implementation. I mean, with respect to data delivery, right? And finally, we can see a high-level architecture. So these are the things we have already discussed. Quite, I mean, we have been discussing. Like we are using a like API connection and then getting that API connection using a Golang service, like that is a capturing, right? So and then processing using a Kafka stream, and then also for the processing we are using a Python here. Okay, so basically the different technologies that you are seeing here, you can so Golang basically why we have used, just to, as a recap, right? We have used for a asynchronous thing, and next is Kafka. So it is used as a, I mean, whenever we are delivering message back, also we are using Kafka, and whenever you are getting that and putting into the archival, so there also they are using Amazon S3 for storing the archival or backup of the data. But important thing where the Kafka is being used is when the data is sent back to the delivered back to the customers and like client applications or client apps. Is Kafka is using Kafka is used here. I mean, with some simple Kafka consumer and a Python combination, they are using it, and they are building a PubSub here. And with that PubSub, they are able to push the message back. So this is the overall architecture, high-level architecture. So entire what we are discussing here. And finally, as a conclusion, we will see what exactly it has benefited to the Hotstar. So emojis become a big hit because it'll definitely show the emotions, or show that the vibe of the uh, event to the end users, and the end users will get connected to the event or the match that is going on. So that's the reason. So it become a huge hit, and they have received around 5 billion emojis from around 55.83 million users during ICICI Cricket World Cup 2019. And also latency is like, so previously it was like, if you're before using considering these technological advancements or technological tweaks with key consideration, it used to be like like approximate 6 seconds, but after that it is come down to 2 seconds. And also we have seen how we can make it configurable. And also availability is like 100% uptime, because so here the technological stack of the are making sure the availability and the scalability are taken care. So that's where the infrastructure is like a more scalable to kind of handle the load, and there is a load balancer and other stuffs here, right? And also not only the advantage with respect to the latency, availability, and other things, but also with respect to the cost, right? So previously it used to be like $1,500 per match, but and it has reduced to like 85%, by 85% after on using this kind of a technological stack. So as you can see, this is the best example where you can minimize the cost using choosing the right technology, and also increase the performance, or increase the revenue out of it, like whatever. So it's just how smartly you choose the technologies, and make the right fit in right place, and taking the consideration of what exactly your expectation or the use case is, and what is the cube that you're going to solve in this kind of a thing. And it is a play of a solution architecture, how a solution architect think and place each components in different places. So it's all about that game, right? So hope this was a useful video to understand how the companies, or the how the different organization, or the different leaders in the market use the technology to kind of bring the huge amount of data, and able to process them, and able to crack the puzzle, and right, so able to achieve the success out of it, right? Hope this was useful, and thanks for watching. And please don't forget to subscribe, and also press bell button for instant notification. Thank you.